Hey everyone, I'm here to teach you about the photoresistor, this component here. So this photoresistor is one of what we call a variable resistor. So rather than the normal resistors that you're used to seeing, like this one, this resistor is going to change its value based on certain circumstances. For this one, the circumstance is how bright it is. So this resistor will actually change the amount of resistance depending on if it's bright or if it's dark. And to use this, we're going to go back to our voltage divider, and we're going to make a couple small changes. So first of all, the resistor between the 5-volt wire and the A0 wire, so for me that's this resistor right here, this one. I'm going to take this out, and in its place I'm just going to put the photoresistor. Pretty simple. So we still have a voltage divider. We have two resistors dividing voltage in half, or in some fraction. The only difference is that our voltage divider is going to give us different values now based on how bright it is. In addition to this, I would like to add an LED circuit to our breadboards so that we can use this information, whatever the photoresistor is telling us, to appropriately dim or brighten or turn off or turn on an LED. So I'm going to start with just an LED. We're used to these guys by now, right? And then I'm going to have it's two legs on two different rows. Now, importantly, I've got to remember that the long leg is on this side, over here. I'm then going to take a resistor. I'm going to put it from the long side of the LED just to another row. And remember that because I'm going across this middle gap here, that this side counts as another row. And then I'm going to take a green wire and put it on the same row as that leg of the resistor. I'm going to go ahead and attach it to pin 5. So pin 5 is a pulse width modulating pin. And putting it there will allow us to not only turn on and off our LED, but if we want to, be able to dim or brighten it as well. Alright, lastly, I'm going to put a black wire on the same row as the short leg of the LED. And I'm just going to attach that to G and D on the Arduino Uno. So we've altered our voltage divider to include this photoresistor, as well as add a new circuit of just an LED. Alright, so now that we've done this, let's go ahead and hop onto Ardublock and get this thing working. Alright, so here I am in Ardublock, and the code that you see up on the screen might be familiar to you. It's the code that we used to find the voltage at the middle of our voltage divider when we did that lesson. Now, we still have a voltage divider, just one that varies, so we can still use this code to see what's going on. So let's go ahead and just upload this. If you just came from the voltage divider lesson, then you probably already have this code on your Arduino Uno. So we're going to upload that and then check the serial monitor. Alright, so it looks like I'm currently at about 4.46 or 4.45 volts. Now let's see what happens if I cover the photoresistor with my hand. So you can see as I dim the area that the photoresistor is in by covering it with my hand, the voltage drops pretty significantly. Let's see how low I can get this to go. Alright, that's about the best I can do. Okay, interesting. So it seems that as I cover the photoresistor, I'm obviously getting less voltage. If I'm getting less voltage, that means that the photoresistor must be gaining resistance. Remember, it's at the beginning of the circuit. So more voltage is being dropped across this resistor, across the photoresistor. So it must be getting bigger. So let's make a little comment here. Let's note that. So I want to note that dimmer, so as the light dims, that is equivalent to saying more resistance. Maybe I'll put little spaces in here. More resistance, which is also equivalent to less voltage. And then likewise, I can say that brighter light is equivalent to, let's see, less resistance, which is equivalent to more voltage. So I'm just going to use that to remind myself in case I forget. Alright, so now that we understand how our new voltage divider functions, let's try to apply it somehow. So I had you put a small or a simple LED circuit onto the breadboard as well. So I think we can use that in tandem with the photoresistor to do something at least somewhat practical. So say if the photoresistor is telling us that it's dark, maybe we turn the LED on as some sort of nightlight, and otherwise we keep the LED off. So why don't we go ahead and try to do that. I'm going to get rid of some of this. However, I'm going to keep this big bundle of math that we have over here. So keep in mind, all of this looks complicated, but that whole section of code, all those blocks put together, just gives us a number between 0 and 5. Remember that. All that mass of blocks is telling us is the voltage. Alright, so I was saying I want us to have the LED on if it's dark, the LED off if it's bright. So I think what I need to do is I need to grab the if-else block because it'll let me do two different behaviors dependent on a condition. Next, I have to grab a test block, and I have to figure out which one is appropriate. So I think either of these, the less than or greater than, or even the less than equal to, greater than equal to could work. I'm just going to grab the first one I see. So the idea is if the voltage read by analog pin 0 is greater than a certain amount, we will turn the light off, and if it's less than a certain amount, we'll turn the light on. Oh, whoops. I didn't mean to do that. Grab it by here. Okay. Okay. No. Alright. Alright, alright. We got there. No problem. The question is, what should that number be? So we want it to trigger changing behaviors based on a certain voltage. So I believe our voltage at when it was bright was at about 4.5 volts, and the voltage when I had my hand placed over it was lower than 2, but we'll say about 2. So between like 4.5 and 2. So I want to put a voltage here that I know we will cross. So I'm going to keep it simple. I'm going to say 3 volts. So I know that as it goes between bright and dark and dark and bright, that it'll cross over that 3 volt boundary. So then let's figure out what this test is saying. It's saying, okay, is the voltage read bigger than 3? So remember that voltage read being bigger than 3 means that it's bright. So this portion of the code will run if this is true. And we'll go ahead and make sure that we have our light off if it's true. So I'm going to say set digital pin. I believe we put it on pin 5 this time around, so that's where our LED is. And because it's bright, we want this pin off. And then otherwise, so when this is not true, then that means it must be dim in the room. So we should keep this on. All right, let's see how this works. At the very least, it uploads correctly. All right, let's take a look at how this works. Okay, so back to our circuit. We have right here, we have the photoresistor. We have the additional resistor, that's the second half of the voltage divider. And then we also have our LED here, same as before. I'm going to go ahead and plug in power to our Arduino Uno, and we'll see if this light behaves the way we want it to. So right now, the light is off, that's good. Now, what happens if I cover up the photoresistor, I limit the amount of light it's getting, and the LED turns on? That's great. So it does work appropriately. I'm going to do one better. I'm going to turn the lights off and see what happens. Okay, cool. So it looks like with the lights off, it is dark enough for the LED to trigger being on. So we're getting less than 3 volts to pin A0 if the light's off. That's awesome. So that worked out exactly the way we expected. All right, I'll see you guys next time.